Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. Now see the remaining questions. Properties of electron that are quantized in Bohr's atomic model are. Here, what is the meaning of quantized? Already in last class we completed its meaning. Quantized means restricted to a particular value. According to Bohr's atomic model, in the atom, energy and angular momentum of the electron are quantized. That means these two properties having a particular value. Electron does not have any value of energy or any value of angular momentum. Energy and angular momentum of electron are restricted to a particular values. This is simply called quantization of energy and angular momentum. So, seventh question, option B is the answer. Okay. Next, the total energy of the electron revolving around the nucleus is less than 0. Already yesterday in previous classes we completed. Total energy of the electron is negative value. Negative value means less than 0. Option B is the answer. Next, when a hydrogen atom is raised from ground state to an excited state, that means from first orbit to higher energy levels, atom goes, that means by absorbing energy, electron goes from ground state to excited state. Then what happens? Potential energy increases and kinetic energy decreases. This point also we completed in the last class. So option B is the answer. Important point. Generally many students will get confusion in this case. Remember carefully. Option B, potential energy increases and kinetic energy decreases. Okay, see the next one. The change in velocity when an electron in hydrogen atom jumps from K shell to L shell. This is representation of energy levels in the atom. K shell means first energy level, L shell means second energy level. Electron jumping takes place from first orbit to second orbit. Then what happens? Its velocity. See, this velocity expression is this one. Vn equal to 2.18 into 10 power 8 into z by n centimeter per second. Now first orbit energy velocity, if we find for hydrogen atom, z value 1, n value 1. So velocity of the electron in the K shell of hydrogen atom is V1 equal to 2.18 into 10 power 8 centimeter per second. Now come to L shell. L means second shell, n value 2. It means we have to divide this value with 2, then we can get half of the value. So what is the option? Twice to its original velocity. Compare it to first shell velocity, second shell velocity is half value. So option B is the answer. Next, delta E is maximum in. 4 options are given, in which case change in energy is maximum. Say this, distance increases from the nucleus. The difference between successive orbits is decreased. That means as we move away from the nucleus, the gap between the energy levels is decreased. The energy levels come close together. So between first energy level, second energy level, more energy gap is there. Second and third, less energy gap. Third and fourth, very less. 4 and 5, very, very less. So which option having maximum delta E means option C, E2 minus E1. First energy level, second energy level, energy gap is more. So in that case, delta E value is maximum. So option C is the answer. Okay. Next, see the next one. As an electron is brought from an infinite distance to close off nucleus of the atom, the energy of the electron. Now electron is present at a far distance from the nucleus. That means electron is present at infinite distance to the nucleus. Now that electron is bringing closer to the nucleus. Then what about its energy? Increases or decreases, or what happens? So when electron is bringing closer to nucleus of the atom, its energy is decreased. That means at infinite distance, it has large energy. When it comes close to the nucleus, its energy gradually decreases and becomes zero. And when it is very closer to the nucleus, its value becomes negative. So coming close to the nucleus of the atom means increases to a greater negative value. So 12th question, option D is the answer. Remember this question also carefully. Based on this, a point is given in the green color box in the NCERT textbook. Okay, important one. Next, see the next one. Note, number of revolutions per second or orbital frequency of an electron in a shell equal to velocity divided by circumference. Velocity Vn divided by, according to Bohr, orbits are in circular path. So formula 2 pi Rn. So from this we can get this one 6.66 into 10 power 15 into z square by n cube. This is number of revolutions formula. Next, time period of revolution of electron in nth orbit. Tn equal to 2 pi Rn divided by Vn, that equal to 1.5 into 10 power 6 minus 16 into z n cube by z square second. Okay, so this is time period formula. This is number of revolutions formula. Now see the important one. If plus 13.6 electron volts energy is given to hydrogen atom, the electron in hydrogen atom will be knocked out, giving rise to the formation of H plus ion. That's why ionization potential of hydrogen is 13.6 electron volts. That means the energy level of first shell with a negative sign. Say this in the hydrogen atom for first orbit. If I say energy E1 equal to 13 point, actually energy formula this one, En equal to minus 13.6 into z square by n square. For hydrogen atom, n value equal to 1, then energy E1 equal to minus 13.6 electron volts. Now ionization potential means same amount of energy is supplied to the hydrogen atom. With that we can remove the electron. Then hydrogen atom change it to H plus. That energy is called ionization potential. Its value plus 13.6 electron volts. Because we have to supply the energy to remove the electron to get H plus ion. So this ionization potential of energy is nothing but negative sign. Actually in hydrogen atom for first shell energy is this one. For this if we take negative value we can get plus 13.6 electron volts. So this is the ionization potential of hydrogen atom. In another way we can say the energy level of first shell with a negative sign. I hope you can understand this one. Next, for hydrogen like species, ionization potential equal to minus E1 into z square by n square. Actually E1 means this one, minus of minus means positive, 13.6 into z square by n square. Okay, see the numerical. What is the ratio of the time periods T1 by T2 in second orbit of hydrogen atom to third orbit of He plus ion? Time period we should calculate. See the answer. For this, we know that time period T is directly proportional to n cube divided by z square. From that, T1 by T2 equal to n1 cube by z1 square into z2 square into n2 cube. Here, n1 equal to 2, z1 equal to 1. That means hydrogen atom second orbit. n2 equal to 3, z2 equal to 2. That means helium third orbit. For this, we have to find out time period ratio. Substitute n1 n2 z1 z2, then we can get this one. So what is the option? Option B is the answer. Okay, this is related to time period numerical. Next, if in Bohr's model for unielectronic atom, time period of revolution is represented as T(nz), where n represents shell number, z represents atomic number, then the value of T12 is to T21 will be. See, it is somewhat a different question because they did not mention particular element or ion, but based on these n, z values we can calculate time period ratio. Say this, we know that time period is directly proportional to n cube by z square. Here T12 by T21, that means T12 means what is n value according to given representation. So this 1 represents n1, n equal to 1, z equal to 2. Z equal to 2 means what is the element? Helium, He plus. Next, T21 means n value 2, z value 1. 1 means hydrogen. So based on this, substitute the values n1, n2, z1, z2. Then we can get 1:32. So understand this type of question carefully. Okay. So option D is the answer. Next, see the next question. The ionization potential for the electron in the ground state of hydrogen atom is 13.6 electron volt per atom. What would be the ionization potential for the electron in the first excited state of Li2 plus? Hydrogen atom ionization potential is given. We should find out ionization potential for Li2 plus for first excited state. First excited state means what is the n value? N equal to 2. Okay. Say this ionization potential for hydrogen like species. That means Li2 plus. What is the formula? 13.6 into Z square by N square electron volt per atom. Here Z value 3, N value 2. Because the first excited state means N value 2. Then we can get this one 30.6 electron volts. Option C is the answer. Okay. Next, see the next one. What is the principal quantum number of hydrogen atom orbital? If the electron energy is minus 3.4 electron volts, also calculate angular momentum of the electron. Okay, principal quantum number, it will come in the next coming topics. Just remember now. So, principal quantum number we should calculate. Principal quantum number symbol is small n. That small n value we should calculate. Hydrogen atom electron energy is given. And we should calculate angular momentum also. Say this. We know that for hydrogen atom energy for first orbit E1 equal to minus 13.6 electron volts. So energy of the nth orbit En equal to E1 divided by n square into Z square is also there, but for hydrogen atom Z value 1. That's why we did not write. Minus, this is given value minus 3.4 equal to minus 13.6 by n square. From this n value we found that is 2. Now angular momentum formula MVR equal to nh by 2 pi. N value, h value, pi value substitute. Then we can get 2.1 into 10 power minus 34 joule second. Okay. So practice well these numericals. In NEET and IIT more chance to ask numerical related to Rydberg equation and energy of the electron from Bohr's theory. Okay, we will meet in the next class.